Hi everyone. It looks like we had a good week learning about hypothesis tests, and now a lot of the discussion posts I see ask about how to determine which formula, and I remember the calculator function that goes with it and all that, so I just wanted to sort of help you decipher or weed through all that information. So the first thing I'll point out is that in our course, on the home page, underneath all the modules, and I've shrunk up the modules that we've completed so far, so those are all there. But right now we're in module 12 or session 12. I have created this little introduction page, and that's where I try to give you some tips on what's different. For example, in blue, we're going to adjust the formulas that we learned in the previous chapters in creating a margin of error for a confidence interval or a test statistic for hypothesis tests. So let me show you what I mean there by using this reference sheet that will be provided on the final exam. If you click it, it downloads it. I printed it out here so I can write on it. Here's page 1, all that stuff we learned in chapter 2 and chapter 3, and then we go down to probability from chapter 5, and 6 for discrete distribution, 7 for the normal distribution. I'll help you with another subsequent video in preparing for the final there. But right here is where we begin to do the confidence intervals. So I don't know why, but statisticians call confidence intervals estimation. We're estimating the parameter, so I guess I do know why. But then it's here, so it'll tell you that you're looking for confidence intervals in the formula sheet. And then what you remember in there is that the confidence intervals are the point estimate, which is here, plus or minus the margin of error. So what we have here is just a big pile of formulas for margin of error. And to help you distinguish what's what, we have one sample, which is the ones you talked about in chapter 9, and now 2 samples, which will be covered this week. So first thing when you read one is to determine what it wants, and when you see the word confidence interval in the problem, then your next question is it a 1 sample or a 2 sample? How much information do I have there? Then once you determine that, that decides you if you're like on the top or the bottom, or help you determine top or bottom. Then you have to determine the parameter that you're trying to estimate. Are you trying to estimate the mean, mu, or the proportion, p? And in setting up this formula sheet, I tried to make it very clear, so you'll see you have like this big line right here in the middle, means on the left, and proportions all on the right. So it's just like a 1 sample, 2 sample, top, bottom, and means left or proportions right. Then of course a little bit further we can make the decision. So if we have means, there's 2 formulas there as well that are based either on the t distribution or the z distribution. And the thing that will make that decision for us is whether or not we have sigma, which is the population standard deviation. If the problem says the population standard deviation is 12 or 19 or 6, then you will use the critical value for z because the standard deviation is known. But if you don't have a population standard deviation, instead you have a sample standard deviation, S, then we use the critical value of t. So that's the deciding factor, and it carries on even when we do it for 2 populations or 2 samples. Either you have both standard deviations here, they're known, so use z, or you don't, and then you will use t. Just read the problem carefully and that will help you decide it. I've seen some really great flowcharts made up from students on how to decide what's what, and I'll post one in Canvas so you can see the flowchart. Now even further from that, like once you are familiar with this formula sheet and how to navigate it, it might be helpful for you to write on this sheet the calculator functions that are associated with this. So estimation are confidence intervals, and confidence intervals are in the stat menu, and scroll over to tests, and then you can scroll down to choose the test or the interval that you want to run. So notice first that we're making intervals. So all the options that you'll want if you're trying to make a confidence interval will end in interval. For example, if you have a mean and it's one sample, estimate the mean, population standard deviation is known, then you want this formula, which depends on z. This means you need the z interval option inside the calculator. If you don't have the standard deviation, you're looking for mean, but the standard deviation is unknown, then you would like to create a t interval. If you don't estimate the mean, you want to estimate p, the proportion, then you will do a 1 prop z interval. And interval won't fit, so it's int, but there's the z in the formula. So this formula sheet can help you decide which calculator function to run if you know where the formulas are in relation to what they're estimating. So similarly, down here in 2 samples now, if you want to create confidence intervals for 2 samples and you follow your formula sheet to decide mu or the rho, the proportion, then you can decide if you have z or a t, right? So this guy's z, but there are 2. This is the 2 proportion z interval. Or if you're estimating the mean and the standard deviation is unknown for the population, then you have t. That's a 2 sample t interval. Or a 2 sample z interval. Interval won't fit at the end of those, so they're just say int in the calculator, so you know. Then those things spit out exactly the confidence interval. So that should help you. Now those things, those fundamentals, will extend to what we did in hypothesis testing last week. This guy's labeled hypothesis testing again. We have stat and scroll over to tests, but now you're actually looking for tests. And we see the same division here. 1 sample or 2 sample, first decide that. And then you have to decide mean or standard deviation this way. 1 sample, 2 sample, means and proportions. Standard deviation known or unknown. Now thankfully for you, I suppose, in this textbook, in this approach, we do no z-tests for means. So in class we do, that's why they're on the formula sheet, but for Pearson takes the approach that everything should be t for tests, which is actually what you see in practice. You never really have a population standard deviation. So in your practice, you can just ignore those 2 formulas altogether in hypothesis tests. So all the hypothesis tests we run will be a t-test. For means, see, all the means depend on t. And for proportions, p, we'll run z-tests. Take note, though, that in the calculator, this would be a 1 prop z-test. You have to tell the calculator that you have a proportion. There is a z-test. It's right over here for the mean, but we don't use that one, right? Instead, we like to use the t-test for mean. T-test is, I think, how it looks. And then when there are 2, a 2 sample t-test or a 2 proportion z for means test. So hopefully that helps you decipher like which formula you need if you're doing it by hand, or which option to run in the calculator. These are good notes to have, a nice little cheat sheet, and you can extend this idea to the previous sections if you're getting ready for the final, or just wait until that final exam week to sort of put it all together. So now that you know how the formula sheet works, I'd like to look at some examples. So back in Canvas, which is here, if you go back to the modules, the main home page, we're in session 12 right now. The next one will be regression, then a quiz, and lastly the final. You can get some details on the final exam, and you can see that I've listed a list of topics and also a review with a practice final. So inside here, if you click on the final review, it's there in PDF. It's a lot of questions, just to give you plenty of practice to see the types of questions and the way they'll be asked on the final exam. So again, you can download that by clicking download. I've put it in here so I can write on it. Let's see how many questions there are. Page 10. 70 questions, answers are at the back, so that's nice. Here, page 7, let's say, you can see some questions on hypothesis testing. Since we just did the formulas for that, let's sort of analyze these questions to determine which test we would run. So we read the question, look for that key information. Airline says no-show rate for passengers is less than 5%. There's a sample of 420 and 12 are no-shows. We also have a level of significance. It says round to the nearest thousandth and test the claim. So as soon as you see test, then you know you're going to run a hypothesis test. That's in case you missed this big bold heading that says we're testing hypotheses. So then you have to decide, is it 1 or 2 sample? And if you look at this problem, we have only one sample size, 420. That means that this is a 1 sample hypothesis test. The next question is, what are we testing? Are we testing a mean, or are we testing a proportion? So in reviewing the information we're given, the question says we think that the rate is less than 5% for no-shows. A rate, or if you even look at the 5%, is a proportion. So now we have a 1 sample proportion that we are trying to test. On the formula sheet, it would look like this. We come to the sheet, we know we're in the 1 sample zone, we know we have a proportion here, so that tells us that a test statistic is z. If you're using the formula, it will look just like this, or you can run the test with the 1 proportion z-test option in the calculator. Let's see what else we can find here. How about number 64? To test the effectiveness of a drug, 200 patients were selected, put into 2 groups. A group of 100 got the pill, and 100 got a placebo. 62 of those taking the drug felt a beneficial effect, while 41 taking the placebo felt a beneficial effect. Do more of those taking the drug feel a beneficial effect than those taking the placebo? Now this one is tricky. There's a lot going on. You might think that there's 1 sample because we had 200 patients, but what we did with those patients was separate them into 2 groups, 100 each. So we actually have 2 different sample sizes, right? Let's skip this one so I can write some notes there. 1 sample size of 100 and another sample size of 100. Of those that took the pill, in the first 100, 62 of them felt a beneficial effect, and of those who did not take the pill, 41 felt better. So it looks like we have a sample, 2 samples, right? And then from there we can create 2 separate proportions, a proportion of people who felt better from the first and a proportion of people who felt better from the second. So while the problem doesn't actually say proportion, it doesn't say mean either, and we're given the information to create a proportion. So this is a 2 sample, where'd it go? 2 sample or 2 proportion z-test. Back in the formula sheet, it looks like this. We have information for 2 different samples, with the pill and without. We're testing proportions. So we have this critical value, or that test statistic, or you can use this formula sheet, calculator formula.